Welcome to the Diagnostic Clinic Focused Learners. I'm your lead strategist, and today we are going to diagnose exactly where students bleed marks on the Cambridge IGCSE Mathematics exam, specifically Syllabus 0580. We're tackling a topic that literally makes students freeze up in the exam hall: composite functions. You know the ones. Those terrifying little letters stacked inside of other letters, like an F, a bracket, a G, an X, and another bracket. It looks incredibly intimidating, right? But here's the secret. Once you understand the underlying machinery, it is incredibly satisfying. Today, we're not just going to learn math. We're going to prescribe the exact cure for those failing answers. We're going to use a clear step-by-step approach drawn directly from the Cambridge syllabus. I see students, let's call one Alex, who just overload their answers with raw math facts but show absolutely zero clear logical steps. And then I see students like Sam who rush through, completely missing the command words and dropping easy marks. We are going to fix all of that right now. By the time we finish this explainer, you'll be diagnosing and curing these equations like an absolute pro.
Okay, let's dive into this. Here is our roadmap for today's session. We've got 5 key areas: the composite function machine, algebraic substitution, numerical evaluation, solving composite quadratics, and independent practice. We're breaking this monster down into highly manageable, distinct skills. Section 1, the composite function machine. Let's set the foundation.
When you see this notation, the letter F, opening parentheses, g of x, closing parentheses, I want you to stop panicking and start visualizing. It's incredibly helpful to frame it in your mind like a factory assembly line. Our source gives us a very explicit, non-negotiable rule here. The expression for g of x is substituted for x in the function f of x. So what does that actually mean for you in the exam? In simple terms, the completely finished output of your first machine, which is the inside G machine, becomes the raw material for your next machine, the outside F machine. You don't multiply them, you don't add them. You literally take the entirety of that g of x expression, swallow it whole, and plug it directly into the empty x space of the f of x equation. It's a substitution game. The output of one is the input of the other. Section 2, algebraic substitution. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at how we actually write this out for full marks.
This brilliantly illustrates how the process flows mathematically. Let's intentionally slow down here, because this is the exact spot where a student like Sam rushes and loses everything. Our source text gives us 2 starter functions. We have f of x equals x squared minus 2, and we have g of x equals x plus 1. Starting with step 1, we want to find f of g of x. So what's our role? We take all of g of x, which is x plus 1, and substitute it wherever we see an x in our f function. That gives us f of x plus 1 equals, in parentheses, x plus 1 all squared minus 2. Now step 2 is the expansion. Listen to me very carefully. Please don't let this part trip you up. This is a classic Cambridge trap. Do not just write x squared plus 1 squared. Remember your binomial expansion rules. An x plus 1 all squared expands out to x squared plus 2x plus 1. You have to have that middle 2x term. And of course we carry down that minus 2 at the very end. Finally, we hit step 3. We simplify the expression. This is where we clean up the messy room. We just combine our constant numbers at the end. Positive 1 minus 2 gives us a negative 1, leaving us with a beautifully simplified, examiner-friendly composite function, x squared plus 2x minus 1. Boom. Full marks for the substitution phase.
Section 3, numerical evaluation. Now we need to figure out what happens when we throw actual numbers into the mix. Now what's absolutely amazing is how simple this next step becomes once that heavy algebraic lifting is completely out of the way. Look at the comparison here. On the left side, we have the general expression we just masterfully simplified, f of g of x equals x squared plus 2x minus 1. On the right side, the exam question asks us to evaluate a specific value. It asks for f of g of 2. Think about what that command is actually telling you. It's saying, hey, wherever you see an x in your brand new equation, replace it with a 2. All we have to do is take the number 2 and plug it straight in. We get 2 squared, which gives us 4, plus 2 times 2, which is another 4. Minus 1. So 4 plus 4 minus 1 effortlessly leads us to the final answer of 7. Do you see how much easier that is? It's literally just a plug-and-play process once your equation is prepped. You don't have to go through the machines twice if you've already built the ultimate composite machine. Section 4, solving composite quadratics. This is it, the boss level. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get back to the strategy.
We are now reaching the highest level task of this entire topic, solving for x when your composite function is set equal to 0. I want to read this quote from the source text aloud, just to normalize the complexity for you. It says, as the quadratic does not factorize, it can be solved either by completing the square or using the quadratic formula. If we set our beautifully simplified expression x squared plus 2x minus 1 equal to 0, you might immediately start trying to bracket it off, but you'll quickly realize something frustrating. There are absolutely no neat, easy whole numbers that multiply to -1 and simultaneously add up to +2. It's a trap. It just won't easily factorize. And you know what? That is completely okay. The Cambridge examiners do this on purpose to test your resilience. When this happens, we simply rely on our trusted quadratic formula to power through the problem.
Let's walk through these final, crucial calculation steps carefully. This is where we secure those top-tier marks. Step 1, we identify our equation, x squared plus 2x minus 1 equals 0. Step 2, we deploy the quadratic formula. Remember, negative b plus or minus the square root of b squared minus 4ac all over 2a. We plug in our a value, which is a hidden 1, our b value, which is 2, and our c value, which is -1. Now, step 3 takes us through the simplification to arrive at our answer. But here is the major key, the absolute crucial point. The final result is written as -1 plus or minus the square root of 2. Notice something there. We didn't reach for the calculator to find out what the square root of 2 is as a decimal. The ultimate goal here, especially in these advanced mathematics papers, is to leave the answer in exact surd form. That means we keep the square root symbol perfectly intact, just as the source text explicitly demonstrates. If you write down a messy, rounded decimal here, you might actually lose that final accuracy mark. Keeping the square root shows perfect, uncompromised mathematical precision. Section 5, Independent Practice Challenges. Let's lock in everything we've just learned. If you want to guarantee your success, the core skills required for the practice exercises are your ultimate checklist. The exam command words will ask you to do 3 things. First, find simplified algebraic expressions for f of g of x. Second, evaluate specific numerical values, like f of g of -1. And third, solve equations set equal to 0 or another number, making sure you leave your answers in exact surd form when necessary. I want to reinforce this heavily. Mastering these 3 specific tasks covers absolutely everything the 0580 syllabus expects from you regarding this particular subtopic. If you can confidently tick off these 3 boxes, you are totally immune to any tricks they throw at you. So let's see how this builds into one last challenge for you to try at home. I pulled this provocative question straight from exercise 4, part C in our source material. Can you solve for x if f of g of x equals 18? Your starting functions are f of x equals 2x squared and g of x equals x minus 1. You have absolutely all the tools you need right now. You know how to build a composite function machine without making silly substitution errors. You know how to expand and simplify the algebra carefully. And you know how to solve the resulting quadratic equation. So grab a piece of paper, test your new understanding right now, and prove to yourself that you've mastered Cambridge IGCSE composite functions. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here.